jump into AI a little bit, you in one of the conversations you had, or one of the videos, you described that one of the things AI systems can't do and biological systems can is self-replicate in the physical world.
Oh, no.
In the physical world.
Well, yes, the physical robots can't self-replicate, but this is a very tricky point, which is that the only thing that we've been able to create that's really complex, that has an analog of our reproductive system, is software.
But nevertheless, software replicates itself, if we're speaking strictly for the replication, in this kind of digital space. So, I mean, just to begin, let me ask a question. Do you see a protective barrier or a gap between the physical world and the digital world?
Let's not call it digital. Let's call it the logical world versus the physical world.
Why logical?
Well, because even though we had, let's say, Einstein's brain preserved, it was meaningless to us as a physical object because we couldn't do anything with what was stored in it at a logical level. And so the idea that something may be stored logically and that it may be stored physically are not necessarily, we don't always benefit from synonymizing. I'm not suggesting that there isn't a material basis to the logical world, but that it does warrant identification with a separate layer that need not invoke logic gates and zeros and ones.
And so connecting those two worlds, so the logical world and the physical world, or maybe just connecting to the logical world inside our brain, it's Einstein's brain. You mentioned the idea of out-intelligence.
Artificial out-intelligence.
Artificial out-intelligence.
Yes, this is the only essay that John Brockman ever invited me to write that he refused to publish in Edge.
Why?
Well, maybe it wasn't well written, but I don't know.
The idea is quite compelling. It's quite unique and new, and at least from my standpoint. Maybe you can explain it.
Sure. What I was thinking about is why it is that we're waiting to be terrified by artificial general intelligence, when in fact artificial life is terrifying in and of itself, and it's already here. So in order to have a system of selective pressures, you need three distinct elements. You need variation within a population, you need heritability, and you need differential success. So what's really unique, and I've made this point, I think, elsewhere, about software is that if you think about what humans know how to build, that's impressive. So I always take a car and I say, does it have an analog of each of the physiological systems? Does it have a skeletal structure? That's its frame. Does it have a neurological structure? It has an onboard computer. It has a digestive system. The one thing it doesn't have is a reproductive system. But if you can call spawn on a process, effectively you do have a reproductive system. And that means that you can create something with variation, heritability, and differential success. Now, the next step in the chain of thinking was, where do we see inanimate, non-intelligent life outwitting intelligent life? And I have two favorite systems, and I try to stay on them so that we don't get distracted. One of which is the Ophrys orchid subspecies, or subclade, I don't know what to call it.
Is that a type of flower?
Yeah, it's a type of flower that mimics the female of a pollinator species in order to dupe the males into engaging in what's called pseudocopulation with the fake female, which is usually represented by the lowest petal. And there's also a pheromone component to fool the males into thinking they have a mating opportunity. But the flower doesn't have to give up energy in the form of nectar as a lure because it's tricking the males. The other system is a particular species of mussel, Lampacillus, in the clear streams of Missouri. And it fools bass into biting a fleshy lip that contain its young. And when the bass see this fleshy lip, which looks exactly like a species of fish that the bass like to eat, the young explode and clamp onto the gills and parasitize the bass, and also use the bass to redistribute them as they eventually release. Both of these systems, you have a highly intelligent dupe being fooled by a lower life form. And what is sculpting these convincing lures? It's the intelligence of previously duped targets for these strategies. So when the target is smart enough to avoid the strategy, those weaker mimics fall off. They have terminal lines, and only the better ones survive. So it's an arms race between the target species that is being parasitized, getting smarter, and this other less intelligent or non-intelligent object getting as if smarter. And so what you see is that artificial general intelligence is not needed to parasitize us. It's simply sufficient for us to outwit ourselves. So you could have a program, let's say, one of these Nigerian scams that writes letters and uses whoever sends it Bitcoin to figure out which aspects of the program should be kept, which should be varied and thrown away. And you don't need it to be in any way intelligent in order to have a really nightmarish scenario of being parasitized by something that has no idea what it's doing.
So you phrased a few concepts really eloquently. So let me try to, there's a few directions this goes. So one, first of all, in the way we write software today, it's not common that we allow it to self-modify.
But we do have that ability now.
We have the ability. It's
just not common.
It's not just common. Yeah. So your thought is that is a serious worry if there becomes
but self-modifying code is available now.
So there's different types of self-modification, right? There's personalization. Your email app, your Gmail is self-modifying to you after you log in or whatever. You can think of it that way, but ultimately it's central. All the information is centralized, but you're thinking of ideas where you're completely this is a unique entity operating under selective pressures, and it changes.
Well, if you think about the fact that our immune systems don't know what's coming at them next, but they have a small set of spanning components, and if it's a sufficiently expressive system in that any shape or binding region can be approximated with the Lego that is present, then you can have confidence that you don't need to know what's coming at you because the combinatorics are sufficient to reach any configuration needed.
So that's a beautiful thing, well, terrifying thing to worry about because it's so within our reach.
Whenever I suggest these things, I do always have a concern as to whether or not I will bring them into being by talking about them.
So there's this thing from OpenAI. So I've next week to talk to the founder of OpenAI. This idea that their text generation, the new stuff they have for generating text is they didn't want to release it because they're worried about the.
I'm delighted to hear that, but they're going to end up releasing.
Yes, so that's the thing. Is I think talking about it. Well, at least from my end, I'm more a proponent of technology preventing so further innovation preventing the detrimental effects of innovation.
Well, we're sort of tumbling down a hill at accelerating speed. Yeah. So whether or not we're proponents or
it doesn't really matter.
It may not matter, but
may not.
Well, I do feel that there are people who've held things back and died poorer than they might have otherwise been. We don't even know their names. I don't think that we should discount the idea that having the smartest people showing off how smart they are by what they've developed may be a terminal process. I'm very mindful, in particular, of a beautiful letter that Edward Teller, of all people, wrote to Leo Szilard, where Szilard was trying to figure out how to control the use of atomic weaponry at the end of World War II. And Teller, rather strangely, because many of us view him as a monster, showed some very advanced moral thinking, talking about the slim chance we have for survival and that the only hope is to make war unthinkable. I do think that not enough of us feel in our gut what it is we are playing with when we are working on technical problems. And I would recommend to anyone who hasn't seen it a movie called The Bridge Bridge on the River Kwai, about, I believe, captured British POWs who, just in a desire to do a bridge well, end up over collaborating with their Japanese captors.
Well, now you're making me question the unrestricted open discussion of ideas in AI.
I'm not saying I know the answer. I'm just saying that I could make a decent case for either our need to talk about this and to become technologically focused on containing it, or our need to stop talking about this and try to hope that the relatively small number of highly adept individuals who are looking at these problems is small enough that we should, in fact, be talking about how to contain them.
Well, the way innovation happens, what new ideas develop, Newton with calculus, whether if he was silent, the idea would emerge elsewhere. Well, in the case of Newton, of course, but in the case of AI, how small is the set of individuals out of which such ideas would arise?
Well, the ideas that the researchers we know and those that we don't know, who may live in countries that don't wish us to know what level they're currently at, are very disciplined in keeping these things to themselves. Of course, I will point out that there's a religious school in Kerala that developed something very close to the calculus, certainly in terms of infinite series, in I guess religious prayer and rhyme and prose. So, it's not that Newton had any ability to hold that back, and I don't really believe that we have an ability to hold it back. I do think that we could change the proportion of the time we spend worrying about the effects of what if we are successful, rather than simply trying to succeed and hope that we'll be able to contain things later.
Beautifully put. So, on the idea of intelligence, what form, treading cautiously, as we've agreed, as we tumble down the hill, what
Can't
form?
stop ourselves, can we?
we cannot. What form do you see it taking? So, one example, Facebook, Google, do want to, I don't know a better word, you want to influence users to behave a certain way. And so that's one kind of example of our intelligence, is systems perhaps modifying the behavior of these intelligent human beings in order to sell more product of different kinds. But do you see other examples of this actually emerging in?
Just take any parasitic system. Make sure that there's some way in which that there's differential success, heritability, and variation. And those are the magic ingredients. And if you really wanted to build a nightmare machine, make sure that the system that expresses the variability has a spanning set so that it can learn to arbitrary levels by making it sufficiently expressive. That's your nightmare.
So it's your nightmare, but it could also be, it's a really powerful mechanism by which to create, powerful systems. So are you more worried about the negative direction that might go versus the positive? So you said parasitic, but that doesn't necessarily need to be what the system converges towards. It could be, what is it?
Well, parasitism, the dividing line between parasitism and symbiosis is not so clear.